Hello aspirants, welcome back to the another session of GATE NPTEL mock test on dated 23rd September 2025 for electrical engineering students. So as you all know, video will be uploaded every Tuesday for electrical engineering students. So without wasting time, let's go into the first question. In before, please subscribe to this channel. If you subscribe to this channel, I get more motivation to give you more questions in less than time and give you more shortcuts for you. So please subscribe and hit the bell icon and comment for any doubt session or any doubts. So let's go into the first question. Is giving that at x1, x0 and y1, y0 be unsigned 2-bit numbers. The function f is equal to 1 if x less than y and f is equal to 0 otherwise. The minimized sum of products expression of f is. So let us assume x be x1, x0 and y be y1, y0. This is our 2-bit numbers, not this one, right? So as per the question conditions, if x less than y, f is equal to 1. If x greater than y or x is equal to y, then f is equal to 0. So to satisfy the every condition, first assume 0, 0 up to 4 times, because 2-bit we can write like 4 times 0, 0, 0, 1, 1, 0, 1, 1, no. So 0 up to 4 times and 0, 1 up to 4 times and 1, 0 up to 4 times and 1, 1, 1, 1 up to 4 times, no. So for y, as you assume the 2-bit numbers crossing, 0, 0, 0, 1, 1, 0, 1, 1. So repeat the cycle up to the last term. So now function given is x less than y. So here see 0 and here 0. X is equal to y, so f is equal to 0 as per the question condition. Here see x is equal to 0, y is equal to 1, so 0 automatically less than 1, so 1. By comparing the each and every term, we get the values of the minterms as this. So we substitute the minterms in the k maps and reduce the k map. So final answer will be got like x1 y1 x1 bar y1 plus x1 bar x0 bar y0 plus x0 bar y1 y0. So this is the answer. So little bit lengthy, but calculation is important. So moving on to the next question, he is given like a 15-bit modulo 32 ripple counter uses JK flip-flops. If the propagation delay of each flip-flop is 20 nanoseconds, and he is asking the maximum clock frequency that can used is equal to. So see, this question can be dealt like we know that it is the general formula, it's not the derived component. So frequency of clock is less than or equal to 1 by n into the propagation delay time of the flip-flop. He has given propagation delay of the flip-flop is 20 nanoseconds and he has given 5-bit modulo, so n is equal to 5. He is asking maximum frequency, if maximum is f clock is equal to 1 by n into t automatically. So f max is equal to 1 by n into t of the propagation delay time. So by calculating this, we get a 10 megahertz. So option D is the correct answer. Next question. So actually this question I didn't got, so after the next lecture I will give you the next video, so please be patient for that. So I go moving on to the next question. So see, he has given consider the MOS differential pair of the circuit below. VCM is 1.1 volts and I0 is 2 milliamperes and RD is 1.5 kilo ohms. Further, the VT of the devices is 0.4 volts. Is asking what is the minimum allowable supply if the transistor remains in saturation. So give your answer in words. Is asking the minimum allowable supply. Is asking the VDD minimum. So let us look into the answer. See, he has given that RD as, so write the given information in one side. VCM he has given 1.1 volts and VT is 0.5 volts and RD is 1.5 kilo ohms and I0 is 2 milliamperes. Here I0 is going out, so here will be the incoming. So I0 can be divided into same equal two parts, because here and here is the same resistance. So I02 is the current for both the resistors. So by knowing the current value and the resistant value, so we can conclude the voltage drop across this resistor. So by calculating voltage drop across the resistor, we got VR as 1.5 volts. Now apply the KVL law of the outer loop. So see here VDD, and so minus VDD plus VR minus VT plus VCM is equal to 0. By doing this, we can get VDD as 2.1 ohms. That's it. This is the easiest question, but we have to mention that the sign of the VT with thyristor, here plus minus, here also plus minus, and if you write here, this also plus minus. Everything will be plus and minus only. So don't write like a minus and plus. So here option is 2.1 volts. So moving on to the next question is from the control system part. He has given the transfer function, so on, and he has given this you already know, 6 dB per octave is 20 dB per decade, and is asking A by B K. So he is asking this the constant which has given. So as we are looking to the answer, so see, both part transfer function can be written as this. For 0 there will be a slope of plus 20. For pole there is a slope of minus 20. So see here we know that pole is on a denominator side and zeros are of a numerator side. See here minus 6 dB per octave, it is decreasing curve for the k, for this is after use for k values. So let us start with here. So minus 6 and here gone to 0, so plus 6 is added to minus 6, so it becomes 0 dB. So we got plus means for at this time corner frequency there is a 0. See, by comparing this to the T1s, as we know that actually I have not written here. From the previous lecture, if you see, it is like 1 plus s by omega c1. So T1 is equal to 1 by omega c1. So corner frequency is s by 2. So here we get like 1 plus s by 2. A is correct only, no, 0.5. So look into the next positive slope. So see, here 0 to 6 positive, so 4. I think here s by 4. So A will be 1 by 4. Yeah, by comparing this for a denominator also, for at which the slope is decreasing at 8, 24 and 36. By comparing the new coefficients, we get A is equal to 1 by 4, B is equal to 1 by 24. So for calculating the K is equal to omega omega power the number of poles in the graph K up to the slope of up to where it's going, like up to 8. Omega is equal to 8, so 8 power number of poles. Here only one pole that is decreasing only, another 2 are increasing, so we keep K is equal to 8 power 1 only. So K is equal to 8. By substituting the value of A by BK, 1 by 4 by 1 by 24 into 8, we get 0.75 as the answer. Sit. Next question. So has given the block diagram of the system shown something like this, and he has given like the transfer function is s by s square plus s plus 2, and he is asking the g of s value by Mason's formula, by substituting here one loop and here another loop. This is not the loop, okay, so there is only one forward path. By checking 1 by s into g into s by 1 minus the loop equations, 1 by 1 g by s minus g by s and minus g and gsg. By calculating this, we get sg by s plus g plus sg plus gs square. So by option verification, by substituting g is equal to s, the same equation is getting the option like option B. The same equation we get as a transfer function. So moving on to the next question. As given plant transfer function as 1 by s square plus 2s plus 4, and the magnitude in decibels of the low frequency asymptote and magnitude plot of the corresponding sinusoidal transfer function is. So is asking like the magnitude dB of low frequency asymptote. So low frequency, we assume omega is equal to 0. Simply substitute s is equal to j omega and find the magnitude value. We get 1 by 4. So in by converting the magnitude value into decibel value, we just keep a 20 log of the desired value. So 20 into log of 1 by 4, we get minus 12.04. So answer is minus 12. Next question. He has given 3 capacitors C1, C2 and C3, whose values are 10 microfarad, 5 microfarad and 2 microfarad. As given, have breakdown voltage of 10 volt, 5 volts and 2 volts respectively. For interconnection shown, the maximum safe voltage in volts can be applied across the corresponding. Is asking the maximum safe voltage and the total charge of the effective capacitance across the terminals. So he has given for breakdown voltage as 10, 5 and 2. We consider the least breakdown voltage 2 volts. So for 5 microvolts, so 2 volts are there. By taking the consideration, so let us assume current is flowing through the our circuit. So let us I1 is going to the C1 and I2 is going to C2 and C3. For series combinations, current will be same. We everybody know. So I2 is equal to V2. Let's consider here voltage as V2 and his voltage V3. So V2 by XC2 is equal to V3 by XC3. By comparing this, we get a V2 as 0.8 volts, because we know that for C3 2 volts is the breakdown voltage. So we get a V2 as 0.8. By as it is in the series, we add the voltages. 2 plus 0.8, you get 2.08. So sorry, 2.8. So safe operating voltage is 2.8 volts. And we also know that basic equation Q is equal to CV. So C equivalent, by everybody knows that in sequence we for capacitors we consider as the resistor in parallel, and in parallel of C we directly add them to get 11.42. So Q is equal to CV. So by substituting the values in the equation, the C equivalent into voltage, it's 11.42 into 2.8, we get 31.976 microcoulomb. So moving on to the next question. He has given that in the circuit shown, the switch S2 has been closed for a long time. At a time t is equal to 0, switch S1 is closed. At t is equal to 0 plus, and the rate of change of current to the inductor in ampere per second is directly asking the di by dt. So is asking for di by dt value. So we consider at t is equal to 0 minus. So see here this switch S1 is not connected and S2 is previously connected for a so long time. For a long time we consider the inductor as a short circuit because it does not allow the change in the current. So by substituting the values of for I is equal to 3 by 2, we get 1.5 amperes as the answer. So moving on to the next time interval, t is equal to 0 plus. So here the both switches are in on condition. So S1 and S2 are closed circuit. So here by considering a node voltage V, by calculating the nodal analysis, so we get a voltage as 2. So by voltage in the inductor formula is V is equal to L into di by dt. So 2 is equal to 1 into di by dt. He has given 1 Henry. So di by dt is equal to 2. That's the answer. So going on to the next question, is asking the impedance looking into the nodes 1 and 2 in the given circuit is. For this type of questions, we keep the voltage voltmeter in the desired place, and simply if he asks the resistance, simply we find out the V by I ratio. So see, so here IB is incoming and 99 IB incoming and I also incoming to the to this node. So by keeping the parallel voltages as same, so see here V by 100 is one outgoing current and these are all the incoming currents. So by following this, we get V by 100 is equal to 100 IB plus I. So here IB is equal to, so here going to from 0 ground level to V. So IB is equal to 0 minus V by 10 kilo ohms. So IB is equal to minus V by 10 power 4. We get is equal to minus V into 10 power minus 4. By substituting the value in IB, we get V by I ratio as 50 ohms. As simple as that. Going to the next question. It has given 230 volts DC shunt motor user drive load such that constant torque motor take 2 amperes, runs up to 1000 rpm, armature resistance 0.5 rpm. Normally the volt load applied. So moving on to the, so he's asking at no load he has given that some armature current, and at the load he has given another armature current 20 ohms. So he's asking if suppose he is connected 3 ohm resistor external resistance in series with armature. So he's asking the full load speed after connecting the 3 ohm resistance. So see answer, for DC shunt motor has given the armature resistance as 0.5 ohms, and we know the equation of a DC shunt motor as Vt is equal to Eb plus Ia Ra. So let us assume no load condition. He has given armature current as 2 amperes and running at 1000 rpm. So we substitute in equation 1. So 230 is equal to Eb1 plus 2 into 0.5. We get Eb1 as 229 volts. That is the equation 2. So considering the next condition, on load condition, he has given that armature current as 20 amperes. So we substitute in equation 1. So 230 is equal to Eb2 plus 20 into 0.5, get 220 volts. So we know that by connecting we know that Eb is proportional to omega and omega is proportional to the speed. So by total we can write back EMF is proportional to a speed. By knowing that we can get a speed as 960.698. Actually this step is not required. So now is given that R external is added. So we in place of armature resistance we write Ra plus R external. So 230 is equal to Eb3 plus 20 into 0.5 plus 3. We get 160. By doing the same analysis from the first part, 160 by 229 is equal to, we assume N3 by 1000, we get N3 as 698.689. So that's it for this question. Moving on to the next question. A single phase 2 kVA 100 by 200 transformer is connected as an auto transformer. Such as kVA rating is maximum. The new kVA rating is asking the kVA rating which is maximum rating. So looking into the auto transformer question, so see this is the easiest question because at which the voltage is less the current is more. So we added the voltages, we get to 300 ohms, and if we consider here the 100 volts, so current is maximum. So current maximum and voltage maximum gives the more kVA rating. So for calculating current he has given 2 kilovolt ampere 2 kilovolt ampere, right? By 100 volts we get I1 as 20. So kVA rating directly multiplying the 300 into 20 we get 6 kVA. So subscribe, hit the bell icon. A video will be uploaded every Tuesday. So moving on to the next question. A 200 volts DC shunt motor has armature resistance 0.5 ohms and field resistance 200 ohms. It takes 2.5 amperes at no load. At full load, motor takes 25 amperes current from the supply. Find the speed regulation. So he has given 200 volts DC shunt. So DC shunt motor and armature resistance as 0.5 ohms and shunt resistance as 200 ohms. So 2.5 amperes at no load and 25 amperes at full load. So calculating shunt resistance, he has given the voltage and the shunt resistance. So 200 by 200, 1 ampere in every load, 1 ampere will be flowing into the shunt resistance. So for consider the no load case, we get armature current as 2.5 minus 1 is equal to 1.5. By applying the motor equation, Vt is equal to Eb plus IRA, we get Eb1 as 199.28 volts. So for full load condition, he has given 25 amperes. So for this shunt, we are get minus 1 is equal to 24 as armature current. So from equation 1, by substituting the values, we get back EMF as 188 volts, and is asking percentage speed regulation. So we know that back EMF is always directly proportional to the speed. So for in place of speed, we assume the voltages at a no load minus full load by no load. By calculating, we get a 5.64% as the percentage speed regulation. So moving on to the next question, a 1600 kilowatts 440 16 pole DC generator runs at 1500 rpm. The number of conductors in the armature 25,000 and the full load armature copper loss is 25 kilowatts. Is asking the value of no load terminal voltage. Actually, this much of data is not required for doing this question. He has given DC generator as 16 kilowatt and 440 16 poles running at 1500 rpm. So by drawing the equivalent circuit, we get for generator EB is equal to IRA plus VT. P is equal to 1600 kilowatt, which is VT into IA. By calculating this, we get armature current as 3636.36 amperes, and he also given that copper loss. Copper loss is formula is I square RA. By substituting the value, we get armature resistance as 0.00189 ohms. So from the first equation, EB is equal to, EB is equal to IA RA plus VT. So we get 446.87. Is asking from the question, he is asking the value of no load terminal voltage. For no load, IA is approximately 0. So then VT is equal to EB. So the value will be 446.87. So moving on to the next question, he has given circuit value. It is an inverting amplifier. So for inverting amplifier, we know that V0 output voltage is minus R2 by R1 into voltage input voltage. We get minus 2 by 1 into 9 minus 18. So here it is exceeding the value of the rating of the op ampere. So we consider up to the fixed value of minus 15 volts. Don't make the answer as minus 18. It is a blunder mistake that everyone do. So moving on to the next question. So is asking voltage V1 voltage. It is simple as the voltage of V0, right? Yes, simply it is the voltage V0. V1 is equal to V0 as per the op ampere. So in the previous lecture, we have given that the formula for calculating the output voltage in which it is not balanced, because 4 by 10 is not equal to 1 by 1. No? So there is a formula. By using that formula, we get V0 as 1 volt. So Vn is equal to V0, that is 1 volt. And next question is asking the sequence component. He has given the positive component, negative component, zero component. Is asking the type of fault in the system. So here every component is independent, which any two are not equal because it is not a ground fault. By adding the every component, we get 0, which is a shortcut of LLG fault. Yeah, easy question. For next question, a power system has 100 buses, including 10 generator buses. For the load flow analysis using Newton-Raphson method, polar coordinates are Jacobian. It is a simpler formula, 2n minus m minus 1 cross 2n minus m minus 1. Here n is the number of buses and m is the number of generator buses, and minus 1 is for slack bus. So for this, we get 189 is to 189. So that's it for today. Please subscribe to this channel for the next video. We'll upload from next Tuesday. So okay, thank you.